Alright, for this review sheet for the final exam for the underclassmen, I'm going to go ahead and do the right side because we'll be using the problems on the left to as examples in class, so I'm just going to go over the right side. So we have an absolute value function here. The vertex, it's kind of hard to see, but it's at -2, -5. So that makes our equation, it's not reflected, so move left 2, x plus 2, and down 5. You can always type that into Desmos or your calculator to confirm. The domain, it's important when you do the domain and range. You know, this is -2, -5. This point over here is on the right and it's going up. This one's on the left and it's going up. So if you look at those, once you write them, your domain is the smallest and the largest x value. So that'd be -infinity to a +infinity. The range is the smallest y to the biggest y. So it'd be -5 with a bracket to infinity. Increasing. So increasing deals with positive slope. So this side has a positive slope. So basically what's happening is from right here to all the way to the right. So from -2 to infinity, that section of the graph is increasing. So you also can use these x values. So before -2, the left side of the graph was decreasing. It has negative slope. I know it's pointing up, but it has a negative slope. The angle of the line is a negative slope. So that's from -infinity to -2. And both ends are pointing up, so positive infinity. Number 4, to solve this, we have to clean it up. So we have to take away 3. So I take away 3 from both sides. I get -20 equals -2 with x minus 4. Divide by -2, so this becomes 10 x minus 4. All right, so now we can split it up into 2 problems. So one of them is x minus 4 equals 10, the original problem, and the other one is x minus 4 equals 10, -10 that is. Because you don't know if it was positive or -10, because the absolute value bars got rid of it. So I got 14 here, and this guy over here we get, what is it, -6. Okay, for letter C down here, f of g of x. So it means that f is the boss. So 4 something plus 1. So inside that space I put x squared minus 5. So I get 4x squared minus 20 plus 1. So my answer is 4x squared minus 19. This says f of g of -2. Now, I could do this 2 ways. I have f of g of x, so I could just put -2 into this problem and get the answer. Or, the easier way to do it, if you don't really have this beforehand, is just literally find the answer to this, g of -2. So if you put -2 in here, -2 squared would be -2 times -2, which is 4. 4 minus 5 is -1. So now I have to do f of -1. So it means I have 4 times -1 plus 5. So -4 plus 5 is 1. All right, number 8, we got the discriminant. So remember your quadratic formula is -b plus or minus the square root. b squared minus 4ac all over 2a. The discriminant is the part inside the radical. So it's the b squared, so 7 squared, minus 4 times a times c. Now when you calculate that, you get 49 minus 60, so you get -11. So when your discriminant's negative, that means you have no real solutions. You have 2 complex or imaginary solutions. So how many real solutions does it have? None. It has 2 non-real solutions. All right, inverses. So over here we have 3 nice points, and we have to reverse them. 2, 3, 4, 5, 6. So -6, -3 would change to -3, -6. All right. -1, 2, 3, 4. 1, 2, 3, 4, 5. So -4, 5 changes to 5, -4. And there's a line between there. And this last one, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 8, 6 will change to 6 and 8. All right. So also remember that the line y equals x, right down the diagonal right here, cuts that in half. So that should be able to look like it cuts your graph in half. All right, over here, solving by factoring. So you're going to have to get everything on one side. So take away x squared. So it gives me 1x squared. Minus 42, this 19x is going to come in the middle of that. So turn into a minus 19x and then minus 42. All right, the 19x belongs over here. It has to be in order. Basically, you know, ax squared plus bx plus c order. Okay. All right, what multiplies 42 and negative 19? So I think we'll do 21 times 2, negative 21 plus 2. All right. There we go. So remember, I have to give my answers, because 1 is equal to 0 of 21 and negative 2. All right, solving using the quadratic formula. So here's my A, my B, and my C. So my quadratic formula says opposite of B. So opposite, so negative of negative 3 would be positive 3, plus or minus square root B squared. So when I square negative 3, I get 9 minus 4 times A, which is 2, and C, which is negative 4. All over 2 times 2. All right, so 9, this turns into plus 32, so that would be 41. All right, and that's finished. You can't reduce 41, so you're done. All right, graphing. So this quadratic function right here, I think I'll do a little sketch up top here. It's moved to the left 2 and up 9. So that coordinate is negative 2, 9, and it's upside down. Okay. Transformations, so a reflection, left 2 and up 9. My domain is from negative infinity to infinity, because a graph goes left and right forever. My range, on the other hand, is negative infinity up to 9, because that's the highest y value. Increasing is the left side, so everything from negative infinity to negative 2. My decreasing area is on the right, so it's everything from negative 2 to the right. Both ends of the graph are going down. Now, to get the X-Intercepts, which are your solutions, solutions, X-Intercepts, and so forth, you're going to want to graph this on your calculator or Desmos, because right now, you know, my little sketch was great and all, but it wasn't like perfect. All right, so we're looking for X-Intercepts. Looks like 1 and negative 5. Oops, positive 1, negative 5. All right, moving on. So in this next picture, we're looking for the solutions to the system of equations. So whenever you have two pictures on a graph or two functions graphed, you want to know where they intersect. So my solutions are the x values where that happens. So no longer do I need the x-intercepts, I need the x value of this place, that would be 2. And this place, that would be negative 2. Okay. Over here, my domain, this graph, it goes left and right forever. And you can see here it goes up and down forever. My solutions are my x-intercepts, that would be negative 2, 1 and 2. So if I turn those solutions into factors, that would be x plus 2, x minus 1, because remember the opposites here, and x minus 2. Increasing. So this is increasing. Look, this point right here is at x equals 1. So it's increasing from the left all the way to 1. So negative infinity to 1. And it's decreasing next from 1 to this place. So this x value looks like 1.5. So I'll say this should be negative 1. From negative 1 to 1.5. and then it's back to increasing again, 1.5 over. So 1.5 and on. All right, my end behavior on the left side is going down, on the right side up. Okay, synthetic division. To divide this by x minus 2, remember I put the opposite number in the box? And I take my leading coefficients, 1x to the third, 3, -5, and -4. So the 1 comes down, 1 times 2 is 2. Add these up, multiply again, add them up, multiply again, and finally there. So this was x to the third, which means this is x squared, and this is x, and remember this is my remainder. So my answer is x squared plus 5x plus 5 plus 6 over what I was dividing by. Okay. All right, for here, let's see, using rational exponents. So what that means to me is I want to have fractions as my exponents. So the cube root of 27 is known, that's 3. My a is going to be 6 over 3. Well, 6 over 3 is 2. And my b is going to be 4 over 3, which doesn't reduce at all. Okay. All right, so that tells me that if I'm going to write this one as a radical, there's a 4 on the bottom, so this means it was a 4th root, just like this was a 3rd. There's no number in front, so I'm just going to put x to the 1st and y to the 9th. All right, so let's see here. I need a square root function. Move to the right 3 and upside down. So to the right 3 would be here, and it's upside down. So normally it would go up, and now it's coming down instead. And remember, you can also put this on your calculator. So negative square root x plus 3, or x minus 3. Okay, so there it is. All right, the parent function would be radical x. Transformations, there's been a reflection and a right 3. My domain is everything from 3 over, 3 to infinity, including 3. And my range is everything below 0, because 0 is the highest that it gets to. So negative infinity to 0. So remember, you always have to put the smaller thing than the larger thing. All right, solving this equation, I got to get this radical alone, and then we'll get rid of it. So let's take away 9. So I get negative 4. Radical x plus 7 equals negative 20. Divide by negative 4, so I'll be left with x plus 7 in the radical. Negative 20 divided by negative 4 is 5. So now is the time when we come in and we square both sides to get rid of the radical. So x plus 7 comes out, and then I equal 25. Take away 7, and you get 18. All right, this one here, we need some factoring. So we have to factor and cancel. So x squared minus 9 factors into x plus 3 and x minus 3. 4x plus 8, I can take a 4 out, leaves me x plus 2. This guy, you can make an x if you want. You get a negative 6 and a negative 1. If you do negative 3 plus 2, that works out. And over here, we got negative 18 and 7. So we'll be using 9 minus 2. And we have to divide those things by 3. So we get x plus 3 and 3x minus 2. All right, now the fun part. Cancel, 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 cancel. So my answer is 4 over 3x minus 2. Right, when we add and subtract, we have to have common denominators. So that means we're going to make one big fraction, x plus 2 and 3x minus 4. 3 is going to have to get 3x minus 4, and the 6x is going to have to get x plus 2. I think I will clean that numerator up over on the side. So the numerator becomes 9x minus 12 plus 6x squared plus 12x. So when I'm done, I can write 6x squared plus 21x minus 12. Now sometimes the numerator factors more or does a little something like, look, I can take a 3 out and maybe it factors, but we're going to be done after this step. All right, solving. So this kind of solving, it'd be best to just easiest to cross multiply. So I have 4x times x minus 2 has to be equal to 6 times x minus 1. So I get 4x squared minus 8x equals 6x minus 6. So I'm going to take away 6x, get everything together. So that's 4x squared minus 14x, and bring over my 6. All right, so everything here divides by 2. So a real easy thing is to just divide both sides by 2. So this becomes 2x squared minus 7x plus 3. Now I should go back and say x, my answers cannot be 2 and 1, because that would make the denominator 0, and I don't want that. So know that for my answers down here. All right, so I'm going to have to factor. And so when we factor, let's see, that'll be 6 and negative 7. So let's see, what multiplies a 6 and makes 7? We'll be using negative 6 and negative 1. I have to divide them both by 2. So I'll get negative 3 and 2x minus 1. So my answers are 3 and 1/2, which do not match what I couldn't have, so I'm okay. All right, asymptotes. So horizontal asymptotes are easy to see. You just compare. The top has a smaller x than the bottom, so the asymptote is automatically 0. Here they match, so I'm going to take 4 divided by 2, so, which is 2. A vertical asymptote is easy to see here. It's whenever the bottom is 0. So when does 2x plus 3 equal 0? If you solve that, you get negative 3 over 2. Now, up top here, I'm going to have to factor to see that. So what multiplies a 6 and makes 5? I'll do a minus 6 and a plus 1. So if I go ahead and do my puzzle, negative 6 and negative 5, I would get what multiplies a 6, negative 6 and plus 1. Okay? All right, now look at this. These cancel. So I don't have a vertical asymptote anymore at negative 1. I only have an asymptote at 6. Okay, logs. Log functions, they have vertical asymptotes controlled by this. So normally the log function has an asymptote at x equals 0. This one gets moved to the right 4. So x equals 4. All right. As x goes to 4, so the function, the graph would look like this. It would be like down here. But as you get closer to 4, the function goes down. And as you get further to the right, it rises. And again, you'd put that on Desmos or your calculator. Right, this is a growth problem. Move to the left 6. So it's basically, it used to be here. Let's move over to the left. So it's like over here. But it didn't get moved up or down. So the horizontal asymptote used to be at 0. And it's still there. Right? As it goes to negative infinity, the graph stays at 0. As it goes to the right, the graph goes up, 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 up. Okay. Write this in log form. My base is r, so log base r. So r to the power 2 equals 25. And here, write this in exponential form. 5 is my base. My power is here, so power there equals 125. That's just about changing the forms. Okay, last page here. All right, so let's add 3 to both sides to clean this up. So we got 16 equals 2 to the 2x minus 6. Now 16 is a power of 2. So 16 is really 2 to the 4th. So I can just drop the 2's and say that 4 equals 2x minus 6. Add 6, get 10, and my answer would be 5. Okay. Here, I'm going to clean this up by dividing by negative 2. So log base 3 of x plus 7 equals 4. Now I'm going to change it to an exponent. 3 to the 4th has to equal x plus 7. So that's 81 equals x plus 7. So subtract 7 from both sides and I get 74. Alright, arithmetic sequences. So, 30th term. So remember the formula for the terms, which we'll give you in a formula sheet. And the formula for the terms is a1 plus n minus 1 times d. So the first term is negative 4. I want the 30th term. I'm doing a30 here. So this would be 30 minus 1, which is 29. And d is adding 5. So pop that into your calculator. So negative 4 plus 29 times 5 is 141. Now the sum of the first 45 terms, so S45. The formula goes like this. So I need the number of things. Well, that's 45. I need the first term, which is easy to see, negative 4. But now I need the 45th term. So I'm going to do like we did up here. We're going to do negative 4 plus 45th term. So 45 minus 1, that's 44 times d, which is 5. So 216. Okay, so I need 45 over 2, that's 22.5, times the answer to this, that would be 212. So 4,770. So instead of writing out 45 numbers and adding them up, this does it for you. All right, geometric. So the 12th term. So notice the common pattern here. The common ratio is we're multiplying by 2, so r equals 2. So my first term is 3. My common ratio is 2. So my nth term is a1, which is 3, times r to the n minus 1. So that's my main formula. They want the 12th term. So the 12th term is 3. And then 2, if I do 12 minus 1, that's 11. So 3 times 2 to the 11th is 6,144. All right, the sum of the first 10 terms, so remember my formula goes like this. a1, 1 minus r to the n, over 1 minus r. So I'll be doing 10. a1 is 3. 1 minus r is 2 to the 10th. On the bottom, 1 minus 2. So I'm just going to put that in my calculator. So 3, 1 minus 2 to the 10th, and 1 minus 2. So 3,069. Alright, 21 horses are in the Kentucky Derby. How many ways can the horses win first, place, second, and third? Win, place, and show. That's first, second, and third in horse terms. So we got 21P3 because it matters who is first, second, and third. So 21, math button. Go over to probability, permutations, and put a 3. Whoa, 7,980. 24 students. How many ways can 2 captains? So they're basically equal like level. So we're going to have 24C2. So same thing. 24 math C2. So 276. All right, see you in class.